Hello everyone, welcome back to the channel. In today's video, we are going to analyze the Everglades hydroperiod using Google Earth Engine. We will compare water presence before and after restoration of effort, calculate trends, and even create a custom interactive legend. So I will explain every single line of code so you will understand why we use each command. So let's start the script. So first, we load the Tiger 2018 US state as a feature collection. This contains all the US state vector feature. So next, we filter this collection to get only Florida using ee.filter.eq named Florida. Then we define the Everglades study area. We use .geometry, .intersection, to clip Florida to a rectangle bounding box. This ensures that all our analysis only cover this area. So next, we center the map on the Everglades with zoom level 10. We also add a black outline to visualize the boundary, Everglades boundary. So always define your area of interest first because this makes all subsequent computation faster and more accurate. Next, we load the JRC dataset. So here we load JRC Global Surface Water Yearly History dataset. This dataset provides annual water presence and classification globally from 1984 to onward. JRC dataset yearly. JRC yearly water classification history. So we have 0 for non-data, 1 for water, 2 for seasonal water, and 3 for permanent water. So we filter the data into our Everglades area with filter bounds so that we only analyze relevant pixel. After that, we create binary water mask. JRC water class has several values. Here we consider 2 for seasonal water, 3 for permanent water. These are our water pixels. We rename the band of water to water for simplicity. We use .eq to select these classes and .or to combine them. We finally .copy properties preserve the date of the image, which is important for later trend analysis. Then we define the pre and post restoration period. So before period we have 1984 to 2000 and the after period is 2001 to 2020. We split the water data into two periods, before and after, 1984 to 2000 and 2001 to 2020. This let us compare the effect of restoration project in the Everglades. So then hydro period calculation. Hydro period is the percentage of a time pixels is water. We calculate it by summing all water pixels per year, dividing by total number of year and multiplying by 100 to get a percentage. We also clip it to our study area to ensure our result don't go outside the study area. Before and after HP hydro period. Then restoration impact. We subtract subtract pre-restoration hydroperiod from post-restoration hydroperiod to see the impact of restoration. Positive value means more water after restoration. Negative value means less. Then slope trend. We add a year We add a year band to each image so we can perform linear regression over time. Linear fit, calculate the trend of water presence per pixel across the year. The slope band scale show increase or decrease of water coverage per year. Visualization palette. So here we are using palettes for hydroperiod, pre, post, and difference and trend. Pre-restoration shades of blue and post orange and difference red, white, green and trend slope is red, white and blue. Also we add the map layer, all layers 1984, 2001, 2020 restoration impact and trend and slope. We visualize all layers with their palettes and proper minimum and maximum ranges. You can see this helps the audience quickly see areas where significant changes. So next is legend. We set the legend in left side and we add title, description and data source label to the legend. These functions create row in the legend with color and numerical label. We loop through the palette and calculate the value for each color using linear interpolation. Here is our legend setting. Add layer with color bar. So now we have a complete hydroperiod analysis ready to use. So after that, click on run and your script is running. Maximize the map. Zoom out. So here we have boundary and hydroperiod 1984 to 2000, 2001 to 2020 and restoration impact and trend flow. First I unselect all area and you can see this is our area of interest and first we will click on 1984 to 2000 see and 2001 to 2020 see the difference. Clearly you can see the difference and the restoration impact red for negative and green for positive impact and slope trend same color red for negative and blue for positive. So this was our analysis. That's all for today in Google Earth Engine tutorial. If you follow along, you know how to clip dataset to an area of interest, create binary watermarks, calculate hydroperiod, compute restoration impact and trend, visualize result with custom palette and a legend. So don't forget to like, share and subscribe for more GE tutorial. See you next time. Take care. Bye.